Here we have an exponential equation and we have to solve for x in this an exponential equation. Okay, let me consider the coefficient rule of exponent. That is, I divide two terms with the same base, that is a to the mth power divided by a to the nth power. So whenever I divide two terms with the same base, what I need to do is I have to take the base ones and subtract the exponents, that is m negative n. Okay, now let's do this one in reverse order. That is, here we have base a and two values are in subtraction of the exponent. So whenever two values are in subtraction of the exponent, so what we need to do is we have to take this base a with each exponent and divide them as we have on the left side. So the same thing I'm going to do in our problem. That is, here we have the base 2 and two values are in subtraction of the exponent. So what I need to do is I have to take this base 2 with this exponent and divide them. Then I'm getting 2 to the x power over 2 square positive. The same thing I can do over here. That is 2 to the third power over 2 to the x power equals to 3. And here we have 2 to the x power in numerator. The evaluation of 2 square is just 4 positive, and the evaluation of 2 to the third power is 8 over 2 to the x power equals to 3. Okay, here in this equation, I find 2 to the x power over here and here. So what I can do is I can plug in a new variable. I mean, I can substitute a new variable for this 2 to the x power. That is, let me assume y equals to 2 to the x power. So to make the solving process easier, I substitute a new variable y for this 2 to the x power. So then the equation will become what? So here we have to write y for this 2 to the x power over 4 positive 8 over, for this 2 to the x power also we can plug in y equals to 3. Okay, now, so we have to simplify the expression we have on the left side, and here we are adding two fractions, but we don't have the same denominator. So, and also one of the denominators is a variable, that is y. So it's not possible to find the least common multiple. If both the numerators are numbers, we can find the least common multiple. So for this one, what we can do is we can do cross multiplication method. That is, we have to multiply the first numerator by the second denominator y. So y times y will become what? So y square, and also the second numerator has to be multiplied by the first denominator, that is 8 times 4 is 32 over, further we have to multiply the two denominators, and I'm getting 4y equals to 3. Okay, now I multiply both sides by 4y to get the denominator 4y on the left side. So this 4y will cancel out. I'm getting y square positive 32 equals to 3 times 4y is 12y. Okay, now I subtract 12y from both sides. When I subtract 12y from both sides, is positive 12y, negative 12y will cancel out. I'm getting y square negative 12y positive 32 equals to 0. Okay, now I have a quadratic equation. I have to solve this quadratic equation. Okay, let's solve this quadratic equation by factoring. Okay, here when I solve the quadratic equation by factoring, I have to look at the coefficient of y square. I mean the leading coefficient. So here we don't find any number in front of y square. So I have to assume there is one coefficient for y square. In that case, I have to consider the constant term. So positive 32. So now I have to get two factors for this constant term, so that the product of the two factors must be equal to positive 32. When I add them, it must be equal to the middle term, I mean the coefficient of y negative 12. So I think negative 8 and negative 4 will work. So when I add them, when I multiply negative 8 and negative 4, I'm getting positive 32. When I add them, I'm getting a negative 12. Okay, so to get the two values for y in this quadratic equation, I just have to do change the signs of the two factors. So here we have negative 8 as one of the factors. If I change the sign negative to positive, then I'm getting y equals to 8. So the other value of y is positive 4. So I just change the sign of this factor to get the second value of y. Okay, now I got two values for y. One is y equals to 8, another one is y equals to 4. Actually, y is a variable taken by us. It has to be replaced by the original stuff, that is 2 to the x power. Okay, now let me replace y in both the equations by 2 to the x power. 2 to the x power equals to 8, and here we get 2 to the x power equals to 4. Okay, to solve for x at the exponent in an equation, always we have to get the same base on both sides of the equation. Once we get the same base on both sides of the equation, we can equate the exponents and we can solve for x. Okay, so here we have base 2. 8 also can be written as a power of 2, because 2 cube is equal to 8. So we can write this 8 as 2 cube. Now two terms are equal with the same base, so we can equate the exponents. Then I'm getting x equals to 3. Now let's consider the second equation over here. We have 2 to the x power equals to 4. So here on the left side we have base 2. On the right side also we should be trying to get base 2. I think 4 is a power of 2, because 4 can be written as 2 square. So we get 2 to the x power equals to 2 square. So here two terms are equal with the same base 2. So we can equate the exponents. So I'm getting x equals to 2. So I get two values for x in the given exponential equation. So x equals to 3 or x equals to 2.